Hi all, let's talk about a place on our planet that's as mysterious as the dark side of the moon. This place is Antarctica. It's a vast white desert of ice, a land of extremes where the wind howls and the temperatures plummet to unimaginable lows. When we picture Antarctica, we often think of an empty, lifeless expanse, a massive sheet of ice covering an entire continent at the bottom of the world. It's the coldest, driest, and highest continent on Earth. But what if I told you that this frozen stillness is just a disguise? What if, beneath all that ice, there lies a secret world? A world that has been hidden from human eyes for millions of years, locked away in darkness and crushing pressure. So, how do you even begin to look for a lake buried under 4 kilometers of solid ice? You can't just wander out with a shovel and start digging, mate. But then, technology gave us a new set of eyes. In the 1950s and 60s, scientists began using a clever technique called radio echo sounding. They would fly planes over the ice, sending radio waves down into its depths. These waves would travel through the ice, bounce off whatever was at the bottom, and then return to a receiver on the plane. By measuring how long it took for these echoes to come back, scientists could build a map, not a map of the surface, but a map of the land beneath the ice. Over a remote part of East Antarctica, the radar readings showed something unusual. The echo that bounced back was incredibly flat and exceptionally strong. It wasn't the jagged, uneven signal you'd expect from bouncing off solid rock. It was smooth, perfectly level, like the surface of a calm body of water. This colossal hidden body of water was given a name, Lake Vostok. It was named after the nearby Russian research station, Vostok Station, which itself has a claim to fame. Vostok Station is officially the coldest recorded place on our planet. The temperature there once dropped to a bone-shattering minus 89.2 degrees Celsius. Let's put Lake Vostok into perspective. It is truly immense. It's about 250 kilometers long and 50 kilometers wide at its widest point, and it's deep, with an estimated average depth of over 400 meters. The volume of water locked away down there is staggering. But the most mind-boggling fact about Lake Vostok is its isolation. Scientists estimate that the ice sheet has sealed this lake off from the rest of the world for at least 15 million years. It's a pristine environment, an ecosystem that has been evolving in complete isolation, in total darkness, for geological time. The Antarctic ice sheet isn't just a static lump of frozen water, you see. It's a dynamic, living thing in a geological sense. It's constantly moving, flowing from the high-altitude interior of the continent out towards the coast. This ice sheet holds about 90% of all the ice on Earth, and about 70% of all the world's fresh water. This colossal ice sheet is actually made of two main parts, the East Antarctic ice sheet and the smaller West Antarctic ice sheet. They are separated by a huge mountain range, the Transantarctic Mountains. Scientists drill deep into the ice, pulling out long cylinders called ice cores. These cores are like frozen time capsules. Each layer of ice corresponds to a year's snowfall. The breakthrough came in understanding heat. Not from the sun, of course, but from the Earth itself. Our planet has a hot, molten core, and this internal heat radiates outwards through the crust. Ice is actually a fantastic insulator. Just think of how an igloo works. It uses blocks of snow and ice to trap body heat and stay warm inside, even when it's freezing outside. So you have this perfect setup. At the base of the ice sheet, you've got the geothermal heat from below trying to warm things up. You have the massive ice sheet above, acting as a perfect insulator and trapping that heat. When these three factors combine in just the right way, the inevitable happens. The ice at the very bottom of the sheet, where it meets the rock, begins to melt. Once you have this meltwater at the base of the ice sheet, it doesn't just sit there. Gravity still works, even under 4 kilometers of ice. Just like water on the surface, this subglacial water flows downhill. Scientists have used radar to map these hidden river systems, and they are vast. Some of these subglacial rivers are hundreds of kilometers long. These rivers of meltwater naturally flow towards the lowest points in the subglacial landscape. They collect in the great basins and troughs that were carved out by ancient glaciers long before the current ice sheet formed. But the story doesn't end there. The system is dynamic. Water flows into the lakes, and it also flows out. Sometimes a lake can become so full that the pressure of the water is enough to lift the overlying ice sheet slightly. The discovery of Lake Vostok back in the 1970s was just the beginning. As radar and satellite technology has improved over the decades, the inventory of known subglacial lakes has exploded. As of today, scientists have identified over 400 of these lakes hidden beneath the Antarctic ice. They vary enormously in size, depth, and age. Some are ancient and stable, like Lake Vostok, while others are much more active, filling and draining on timescales of just a few years. There's Lake Ellsworth in West Antarctica, which is much smaller and younger than Vostok, but is thought to be similarly sealed off. Then there's Lake Whillans, which is very different. It's a shallow, active lake that is part of that interconnected plumbing system we talked about. Our story now zooms in on one particular spot in this vast frozen continent. This is Vostok Station, a Russian research outpost established way back in 1957. For scientists living and working here, it's like being on another planet. The air is thin, the isolation is absolute, and the cold is legendary. In the 1970s, a team of British scientists were flying over this region as part of their airborne radio echo sounding surveys. But as they passed over the area near Vostok Station, the radar signal suddenly changed. The jagged, uneven line that represented the rocky bottom went perfectly, unnervingly flat. It wasn't just flat. The echo that came back was incredibly bright and strong, a telltale sign of a liquid water reflector. The breakthrough came in the 1990s as technology caught up with the mystery. More advanced radar systems, combined with precise satellite measurements, allowed scientists to revisit the Vostok anomaly with unprecedented detail. New airborne surveys, flown by researchers from the Scott Polar Research Institute, crisscrossed the region, methodically building a comprehensive map of the feature. The picture that emerged was staggering, but it was satellite altimetry that provided the final, irrefutable proof. Satellites like the European ERS-1 used radar to measure the height of the ice sheet's surface with incredible precision. They found that the ice directly over the mapped lake was almost perfectly flat, deviating by only a few meters over hundreds of kilometers. This could only mean one thing: the ice was floating on a massive body of liquid water below. As fate would have it, another major scientific project was already underway right on top of this newly confirmed lake. For decades, the Russian team at Vostok Station had been painstakingly drilling deep into the ice. By the 1990s, the Vostok ice core had reached a depth of over 3 kilometers, providing an incredible 420,000-year record of Earth's climate and atmosphere. But as the drill bit deeper, it was approaching the mysterious interface between the ancient ice and the hidden lake below. The ice they were recovering from the very bottom of the core was different. Scientists realized it was accretion ice, lake water that had frozen onto the bottom of the ice sheet. They were now analyzing ice that was once liquid water from the surface of Lake Vostok itself. The combination of the lake's confirmed existence and the potential discovery of life in the overlying ice core catapulted Lake Vostok from a niche scientific topic into the global spotlight. It was no longer just a Russian project. It became a major focus of international scientific interest. Organizations like NASA became heavily invested, not just for the biological potential, but because of what Lake Vostok represented for astrobiology. The conditions in the lake, liquid water beneath a thick ice shell in total darkness with potential energy from geothermal sources, were strikingly similar to those believed to exist on Jupiter's moon Europa and Saturn's moon Enceladus. So, Lake Vostok was suddenly seen as the perfect Earth-based analog for testing technologies and strategies for finding life on other worlds. So picture the scene. You've found a pristine, sealed treasure chest, possibly containing the secrets of life itself, and it's buried under 4 kilometers of solid, moving ice in the coldest place on Earth. The conditions are beyond extreme. At the surface, you have temperatures that can freeze exposed skin in seconds and make steel as brittle as glass. Then there's the ice itself. You're not just drilling through a static block. The Antarctic ice sheet is a glacier. It flows. This means the borehole, the long, thin tunnel you're drilling, is constantly being squeezed and deformed. On top of the physical challenges, you have the pressure problem. At the bottom, just above the lake, the pressure is about 400 times greater than the air we breathe at sea level. The team with the most experience in this daunting task was, of course, the Russian Antarctic expedition at Vostok Station. Their method was a testament to robust, old-school engineering. To keep the borehole from collapsing under the immense pressure, they filled it with a mixture of kerosene and freon. These chemicals were chosen because they are less dense than water and have a very low freezing point. However, as the drill inched closer to the lake, this method became a source of intense international debate. The problem was the kerosene. The borehole contained over 60 tons of this fluid. The Russian engineers were well aware of these concerns and began to devise a clever plan to avoid direct contamination. Their strategy relied on a precise understanding of the pressures involved. The central fear that overshadowed the entire Lake Vostok drilling project was the risk of contamination. This wasn't just about being tidy, it was about the fundamental integrity of the science. Lake Vostok is, a time capsule. Its value lies in its isolation. If we were to introduce modern surface-dwelling microbes into the lake, it would be like a historian spilling coffee all over a priceless ancient manuscript. This threat of contamination led to a voluntary moratorium on drilling in 1998, a decision that was praised by the international scientific community. The Russian team halted their drill just 120 meters above the lake surface. It was a crucial moment where the scientific principle of do no harm took precedence over the race to be first. The world agreed that it was better to wait and get it right than to rush ahead and risk destroying a unique natural laboratory. The pause in drilling sparked a wave of innovation and international collaboration. Scientists and engineers from around the world began to design and propose alternative technologies for cleanly accessing subglacial lakes. The American scientific community, for instance, focused on developing a hot water drill. This technique uses a high-pressure jet of heated, filtered water to melt a hole in the ice. Another promising technology was the development of robotic probes or cryobots. These were envisioned as sophisticated autonomous robots that could melt their way down through the ice sheet. While these advanced technologies were being developed, they were primarily aimed at other, more accessible lakes like Lake Ellsworth in West Antarctica. After years of careful planning, environmental assessments, and technological refinements, the Russian team was ready to resume the final push. In 2006, drilling at Vostok recommenced with a renewed sense of purpose. The team drilled slowly and methodically, using a new thermal drill head coated with a clean silicone oil lubricant instead of the kerosene mixture for the final stretch. Finally, in February 2012, after decades of effort, they made history. The drill sensors indicated a sudden change. The resistance vanished. They had broken through. The breakthrough was executed exactly as planned. Just as the engineers had predicted, the immense pressure differential forced a column of pristine lake water up into the bottom of the borehole. The journey of the Lake Vostok ice core from the bottom of the world to the pristine laboratories was an epic in itself. These cylinders of frozen lake water were more precious than gold. The cores were carefully sliced in ultra-clean rooms, with researchers dressed in full sterile gear, looking more like astronauts than geologists. In 2013, the Russian team announced they had found the DNA of a previously unknown bacterium in the samples. It was a fragment of a life form that didn't match anything in the existing genetic databases. However, the scientific process is built on verification and skepticism, and these findings were immediately met with intense scrutiny. The big problem was proving that this DNA wasn't just a contaminant. Let's imagine for a moment that the hints are real, that there is a genuine native ecosystem thriving in the dark waters of Lake Vostok. What would that life even look like? It would have to be what we call an extremophile, an organism that loves extreme conditions. For energy, it couldn't rely on sunlight like plants do. Instead, it would have to be chemosynthetic. One of the most intriguing aspects of Lake Vostok is that the water is thought to be supersaturated with oxygen. For most life on Earth, that much oxygen would be highly toxic. Over millions of years of isolation, these microbes could have evolved into species and strains completely new to science, with unique biochemical pathways we've never seen before. Beyond the tantalizing search for life, the water from Lake Vostok is a scientific treasure for what it can tell us about the planet itself. The water is a liquid archive of geological and climatic history. The types of dissolved minerals, for example, can tell us about the rocks that make up the lake bed, providing clues about the geology of a region that we can't see directly. Ultimately, The lake is a complex, interconnected system. The geology of the bedrock influences the water chemistry. The water chemistry influences the potential for life. Studying the first samples from Vostok was like finding the Rosetta Stone for this hidden world. It provided the first real data points, allowing scientists to start deciphering the language of this unique environment. The importance of Lake Vostok extends far beyond the icy shores of Antarctica. Several moons in our outer solar system look remarkably like Lake Vostok, but on a planetary scale. Lake Vostok is our perfect practice ground. The challenges of exploring it are immense, but they are a small-scale dress rehearsal for the even greater challenges of sending a robotic probe to another world. If we were to find a thriving, complex ecosystem in Lake Vostok, it would be a game-changer for astrobiology. It would provide a powerful proof of concept that life can exist in cold, dark, sub-ice oceans. It would tell us that sunlight is not a necessary ingredient for a biosphere, and that the habitable zone around a star might be much wider than we thought. When you're preparing to explore one of the last pristine environments on Earth, the number one rule is simple: do no harm. This isn't just a friendly suggestion, it's a core principle of the entire endeavor, often referred to as planetary protection. This principle of protection is a two-way street. The first and most obvious concern is forward contamination, the risk of us introducing our modern surface world microbes into the ancient lake. This deep sense of responsibility is enshrined in international agreements like the Antarctic Treaty System, which designates the continent as a natural reserve devoted to peace and science. Before any team can drill into a subglacial lake, they must submit a comprehensive environmental evaluation. This document, which can be thousands of pages long, details every step of the proposed project. To understand how these principles work in practice, we can look to the successful exploration of another, very different subglacial lake, Lake Whillans. In 2013, an American team, under a project called Wizard, successfully drilled through 800 meters of ice. Their mission was a masterclass in clean access technology. The entire project was designed from the ground up, with contamination prevention as its absolute highest priority. Every piece of equipment that was destined to enter the borehole and the lake was subjected to a rigorous cleaning process. The instruments were first washed with hydrogen peroxide and then baked in an oven. When the team analyzed the first water samples from Lake Whillans, they found a thriving community of microbes. The Whillans project proved that clean access is possible, but it requires an obsessive level of care and planning. The ethics of exploring subglacial lakes go deeper than just preventing microbial contamination. Antarctica is one of the last great wildernesses on Earth, a continent largely untouched by direct human industrial activity. Some environmental groups and scientists have argued for a permanent moratorium on subglacial lake drilling, believing that the risk of an irreversible mistake is simply too high. The discussion also involves questions of national interest and international cooperation. The initial drilling at Vostok was a Russian national project, but the lake itself is a feature of planetary significance. Ultimately, the ethics of under-ice science force a sense of humility upon us. We are visitors in an ancient environment that has existed without us for millions of years. So where does this leave us on our journey into the heart of the Antarctic mystery? We've peered through kilometers of ice, we've mapped a hidden world of mountains and water, and we've even managed to gingerly touch and sample the surface of the Great Lake Vostok. Yet for all our incredible technological achievements and painstaking work, the biggest questions remain tantalizingly unanswered. The core mystery, is there a living, breathing ecosystem in Lake Vostok, is still out there, waiting in the dark. The next generation of missions will need to be even more ambitious. Scientists dream of deploying a fully autonomous, sterile, robotic submersible that can leave the borehole behind and swim freely through the vast, dark waters of the lake. The future of Antarctic exploration is not just about Vostok either. With over 400 subglacial lakes now identified, we have an entire library of hidden worlds to investigate. Ultimately, this entire epic tale of ice and uncertainty comes down to one fundamental human trait: our restless curiosity. We are a species that looks at a blank spot on the map and feels an irresistible urge to go and see what's there. For centuries, Antarctica was that blank spot, the terra australis incognita, the unknown southern land. We have since mapped its surface, climbed its mountains, and reached its pole. Now the frontier has moved downwards. The questions we ask of Lake Vostok are the same fundamental questions we have asked for millennia. What is life? How does it begin? How resilient is it? Could it exist elsewhere? Finding life in Lake Vostok would be a profound moment for humanity, a discovery that would forever change our perspective on our own planet and expand our imagination about what is possible in the cosmos. The story of Lake Vostok is a powerful testament to what we can achieve when we combine audacious goals with persistence, international cooperation, and a deep sense of responsibility. And so, the Great Lake remains, silent and dark, guarding its ancient secrets. It waits patiently, as it has for millions of years, beneath its colossal shield of ice. But as long as there is mystery, there will be curiosity. And as long as there is curiosity, we will keep striving, keep innovating, and keep dreaming of the day when we can finally reveal, once and for all, what truly lies beneath the ice at the bottom of the world. The search is far from over. In fact, it's only just begun.